NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will master how to add and subtract radical expressions. We will build intuition, fix common mistakes, and work through clear examples. First, an important warning. In general, the square root of a sum is not the sum of square roots, and the square root of a difference is not the difference of square roots. Let us verify with quick counterexamples. 9 and 16. The square root of 9 plus the square root of 16 equals 7, but the square root of 25 equals 5. 136. 10 minus 6 equals 4, but the square root of 64 equals 8. So, they are not equal. So what does work? Combine like radicals, same number under the root. Think of the radical part as the variable. Coefficients, add or subtract. For instance, 2 root 3 plus 5 root 3 equals 7 root 3. Strategy. Step 1. Simplify each radical by pulling perfect squares out. Step 2. Combine like radicals. For example, the square root of 8 equals 2 root 2 because 8 is 4 times 2. The square root of 18 equals 3 root 2 because 18 is 9 times 2. We will use this in our examples. Example 1. 3 root 5 plus 2 root 5 minus 1 root 5. Combine coefficients of the same radical 5. 3 plus 2 minus 1 equals 4. So the answer is 4 root 5. Example 2. The square root of 8 plus 3 root 2 minus the square root of 18. Simplify each radical first. 2 root 2 plus 3 root 2 minus 3 root 2. Now combine like terms. The 3's cancel, and the result is 2 root 2. Example 3. 5 root 12 minus 2 root 27 plus the square root of 75. Simplify each. 10 root 3 minus 6 root 3 plus 5 root 3. Now, add coefficients. 10 minus 6 plus 5 equals 9. So we get 9 root 3. Final example mixes radicals with plain numbers. For plus the square root of 2 plus the square root of 50 minus 2 times the square root of 8. Simplify radicals. For plus 1 root 2 plus 5 root 2 minus 4 root 2. Combine like radicals and keep the constant. That is 4 plus 2 root 2. Recap. Simplify radicals by pulling out perfect squares. Then combine like radicals by adding or subtracting their coefficients. Never split a square root over addition or subtraction. With these rules, radical addition and subtraction become straightforward. Example. First problem, 2 root 3 plus 5 root 3. We start by grouping like radicals, and then we add the coefficients. Step 1. Combine like radicals by factoring the common square root of 3. This gives open parenthesis 2 plus 5 close parenthesis times root 3. Step 2. Add the coefficients. 2 plus 5 becomes 7. Example. Second problem. The square root of 3 over 3 plus the square root of 3 over 2. We will form a common denominator, then factor out the common radical, and finally add the numbers. Step 1. Use a common denominator of 6. This gives a single fraction with numerator 2 root 3 plus 3 root 3, all over 6. Step 2. Factor the common square root of 3 from the numerator. This becomes open parenthesis 2 plus 3 close parenthesis times root 3 over 6. Step 3. Add 2 over 6. Step 3. Add 2 and 3 to get 5. That yields 5 root 3 over 6. Example. Third problem. For root 2 minus 2 root 2. This is again a like radical situation. Step 1. Group coefficients. Open parenthesis 4 minus 2 close parenthesis times root 2. Step 2. Subtract 4 minus 2 to get 2, so the result is 2 root 2. Quick recap. The expressions are 5 root 2 plus 3 root 2 minus 9 root 2 plus 5 root 2 over 3, 3 root 32 minus 5 root 2, and square root 45 minus 3 root 20 plus 2 root 5 plus root 7 minus root 63. We start with expression 1. Rule. Combine like radicals. Group the common radical root 2 by adding the coefficients. Convert to thirds and add 2 over 3 times root 2. So the simplified result is 2 over 3 root 2. Now, the second expression. Rule. Factor perfect squares under the radical. Rewrite 32 as 16 times 2. Separate the radical and simplify root 16 to 4. Multiply, and then combine like radicals to get 7 root 2. For the third expression, we again pull out perfect squares and then combine like terms. Rule: factor perfect squares and combine like radicals. Replace 45 by 9 times 5, 20 by 4 times 5, and 63 by 9 times 7. Evaluate the perfect square roots. 3 root 5 minus 3 times 2 root 5 plus 2 root 5 plus root 7 minus 3 root 7. Combine the root 5 terms and the root 7 terms. The result is negative root 5 minus 2 root 7. I will show the problem list under the label example. Then we will solve each expression step by step, always stating the rule in a tip box before the step appears. Rule box: combining like radicals. Step 1. Simplify cube root of 4 plus 2 cube root of 4. We combine coefficients 1 and 2 to get 3 times cube root of 4. Rule box: combining like radicals. Step 2. Simplify 3 cube root of y minus 2 cube root of y. That equals 1 cube root of y, or just cube root of y. Rule box: factor perfect cubes inside a radical. Step 3. Simplify 4 cube root of 5 plus cube root of 40. Write 40 as 2 cubed times 5. Split the cube root into cube root of 2 cubed times cube root of 5. Cube root of 2 cubed is 2, so we combine 4 cube root of 5 and 2 cube root of 5 to get 6 cube root of 5. Rule box: combining like radicals. Step 4. Simplify radicals. Step 4. Simplify 5 cube root of 6 minus 2 cube root of 6. Combine the coefficients to get 3 cube root of 6. Rule box: product rule for radicals and factoring perfect cubes. Step 5. Simplify cube root of 8, y minus cube root of y to the 4th. Split each cube root into factors. Compute cube root of 2 cubed as 2, and cube root of y cubed as y. Now factor out cube root of y to write the result as parenthesis 2 minus y times cube root of y. Here are the simplified results in order. Quick challenge: the square root of 25 over 9 minus the square root of negative 5/9 squared. We will simplify square roots and powers, then handle the double negative, combine fractions, and finish. Rule: simplifying square roots and powers. The square root of a squared equals absolute A. Also, the square root of a fraction equals the fraction of the square roots. Step 1. Simplify both square roots. Rule: double negation. Minus of minus A equals A. Step 2. Remove the double negative to get 5/3 minus 5/9. Rule: subtracting fractions with a common denominator. A over C minus B over C equals a minus B all over C. Step 3. Rewrite with a common denominator of 9, giving 15 minus 5 over 9. Rule: simplify the numerator 15 minus 5 equals 10. Step 4. The result is 10/9. Problem 2. 5 times the square root. 5 times the square root of 9 plus the square root of negative 4 squared minus 4 times the square root of negative 3 squared. Apply the square root and power simplification rule again. Step 5. Evaluate each square root. Use double negation again to remove the minus signs. Step 6. Compute. 5 times 3 is 15, plus 4 minus 12. Rule: perform the additions and subtractions left to right. Step 7. The result is 7. Problem 3. 2 times the square root of 25 over 36 minus the square root of negative 5/6 squared. Apply the same square root and power rule again. Step 8. Evaluate both square roots. Remove the double negative again. Step 9. Simplify to 10/6 minus 5/6. Now subtract the fractions with a common denominator. Step 10. The result is 5/6. Great work! Our final answers in order are 10/9, 7, and 5/6. Quick challenge: can you create a similar problem by changing the numbers and follow the same steps? We simplify the expression. Cube root of 81 plus cube root of negative 24 minus cube root of 0.003. We'll factor perfect cubes first, then separate the cube roots. Next, evaluate perfect cubes. Combine like terms. Finally, simplify the coefficient to get the answer. Example 2. We simplify a fraction with radicals. We'll first combine like radicals in the numerator and denominator, then cancel the common factor square root of 3. This yields the simplified fraction. Example 3. Expand the binomial with square roots. We'll use the square of a difference formula. Then simplify the squares of the square roots. Next, we simplify the middle radical term. Finally, combine constants to finish. To summarize, our answers are 9/10 times the cube root of 3, 3/4, and 9 minus 6 times root 2. These steps showcased factoring perfect cubes. We show the problem list, then we solve each one step by step, highlighting what's changing at every step. Step 1. We apply the rule for combining like radicals. Coefficients of the same radical can be added or subtracted. Start with 4 root x minus 5 root x. Factor the common root x to get left parenthesis 4 minus 5 right parenthesis root x. For minus 5 is -1, so we have -1 times root x. That simplifies to negative root x. Step 2. We restate the general rule as a template. So a root b plus c root b equals left parenthesis a plus c right parenthesis root b. Step 3. Use power and product rules for roots. The square root of m squared is m when m is positive, and the square root of a product equals the product of the square roots. Assume a and b are positive. Rewrite the first root as the square root of open parenthesis, a b squared close parenthesis squared. Split the second root as square root of a squared times square root of c. Now evaluate the square roots to get a b squared minus a times root c. Finally, factor on the right to right left parenthesis b squared minus root c right parenthesis times a. Great work! Here are the simplified results. Combine like radicals. Since all terms are square root of 5, we add the coefficients. That gives us parentheses 3 plus 2 plus 4 times square root of 5, which equals 9 square root of 5. Problem 2. We'll first rewrite each radical using a perfect square factor. Use the rule, the square root of a square times b equals a times square root of b. So we write square root of 8 equals square root of parentheses 2 squared times 2, square root of 32 equals square root of parentheses 4 squared times 2, and square root of 18 equals square root of parentheses 3 squared times 2. Next, separate the perfect square and the remaining factor. That becomes 2 root 2 plus 4 root 2 minus 3 root 2. Combine like terms to get 3 root 2. Problem 3. Simplify inside the radicals first. 2 squared plus 3 squared equals 4 plus 9. So the expression becomes 4 root 13 plus root 52. Now simplify the second radical using a perfect square factor, 4 times 13. Split it into square root of 4 times square root of 13. That is 2 root 13. So together with 4 root 13, we get parentheses 4 plus 2 close parentheses times root 13, which equals 6 root 13. Summary. We simplify by 1. Extracting perfect squares, 2. Converting each to coefficient times radical, and 3. Combining like radicals. Practice these steps on your own to build speed and accuracy. Example. We start with the expression square root of 98 minus square root of 50 plus square root of 128. Step 1. Break each radicand into a perfect square times a leftover factor. We use the rule, the square root of a times b equals the square root of a times the square root of b. Step 2. Extract each perfect square. The square root of a squared times b equals a times the square root of b. Step 3. Combine like radicals. All terms are multiples of square root of 2. Example. Next expression, square root of 27 minus square root of 2 squared times 3 minus square root of 75 plus square root of 48. Step 1. Write each radicand as a perfect square times 3. Step 2. Extract the perfect squares. Step 3. Combine like terms. The coefficients add to 0, so the entire expression equals 0. Example. Finally, a cube root problem. 5 cube root of 2 plus 3 cube root of 54 minus 4 cube root of 128. Step 1. Express each radicand as a perfect cube times a leftover factor. For cube roots, the cube root of a times b equals the product of the cube roots. Step 2. Extract perfect cubes. The cube root of a cubed times b equals a times the cube root of b. Step 3. Combine like cube roots. 5 plus 9 minus 16 equals -2, giving -2 times the cube root of 2. Example. First expression. 5 square root of 2 plus 3 square root of 2 minus 4 square root of 2 plus 2 square root of 2 minus 1 square root of 2. The rule. To combine like radicals, add or subtract the coefficients in front of the same root. So we write an open parenthesis, 5 plus 3 minus 4 plus 2 minus 1, close parenthesis times square root of 2. Now compute the sum inside the parenthesis to get 5 square root of 2. Second expression, 2 15th root of 8 minus 3 5th root of 2 minus 4 15th root of 8 plus 8 5th root of 2. Group like radicals. This equals open parenthesis 2 minus 4 close parenthesis times the 15th root of 8 plus open parenthesis -3 plus 8 close parenthesis times the 5th root of 2. That simplifies to -2 15th root of 8 plus 5 5th root of 2. Next, convert the 15th root of 8 into a power of 2 that matches the 5th root. 8 is 2 cubed, so the 15th root of 8 is the 15th root of 2 to the third. Write -2 times the 15th root of 2 to the third, plus 5 times the 5th root of 2. Because 3 over 15 reduces to 1 over 5, the 15th root of 2 to the third is the 5th root of 2. Now, both terms are 5th root of 2, so we combine coefficients. -2 plus 5 equals 3. The final answer is 3 5th root of 2. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.